2-7 homework was your inequality. So on 16, 8, and 19, you have to talk about its behavior. So on 16, -2 is a 0, 9 is a 0, i's are 0. So you don't need something on your number line for that. So -2 has a multiplicity of 3. So that means I need to do one sign graph. 9 has a multiplicity of 4, so it's always positive. So I don't need a sign graph. So I believe this question wanted all of them. So it is equal to, at -2 and 9, it is less than from -infinity to -2, and it is greater than, I guess you would have to do -2 to 9 union 9 to infinity for just greater than, right? Because at 9 it's equal to. If it was greater than or equal to, then you could go -2 to infinity. So the same thing with 19. So you factor the x squared minus 3x plus 2, -1 for the first one, normal sine graph, 2 for the second one, normal sine graph, 1 for the last one, normal sine graph. So it's less than. So we're looking for a negative. So -infinity to -1, union 1 to 2. So any issues on those two? Okay, let's see what the next ones were. Okay, on 26, it was the same thing, right? An inequality, but that wasn't factorable. So you actually needed to graph it. That was the graph of it. So we're looking for less than 0. So it would be 0.388 to infinity. You're not going to have your graphic calculator on that one, so you don't have to worry about anything that is not factored. Okay? So now 28. I think 28 can definitely be a tricky one. Okay, so what I did, right, because this one is kind of a weird one. So I factored a negative out, and I just rearranged it to look a little better. So I think when you rearrange it and you look at it a little better, you can tell this is always positive. This is always positive. So if I have two things that are always positive, and then you have to multiply it by a negative, then this whole function is always going to be negative, which means it's below the x-axis. So it's never positive. It's never equal to 0. It is always negative or equal to 0. So I think you had to do that little rearrangement with 28 to make it a little easier. 30, same deal, right? 30 looks like x squared plus 4, 3 minus 2x all squared. So actually maybe you don't need to do rearrangement for that one, because always positive or 0. So at x being 3/2, it equals 0. So on that one, I think it was the same direction, as 28. So it's going to be greater than or equal to 0 everywhere. It's never negative. This one would be equal to 0 at 3/2. And then this one, I think we would just need to take 3/2 out because it is equal to at 3/2. I'm not going to really ask you to do all 4 of them. I'm going to ask you more to do something like this or the rational function. On which one? Yeah? On D?
Yeah.
Yeah. No, 3 halves. Yeah. Unless I wrote it wrong. Did I write it wrong? Let me look at what they say back here. Let's see if there's answers. What did somebody say? Let me see what they say back here. Again, it could be a typo in the back of the book, right? Or the answer key. Which one is this one? This one is 30. Yeah, they don't have the answers back there. I think it's 3 halves. I don't think it's 4. All right, let us see what else we got. Okay, so these two were equations. So you're going to take both of them. You're going to multiply by the LCD. So I got these 2 lines when I multiply by the LCD. So on this one, I multiply it all out. I rearrange 8x squared minus 13x minus 2. I don't think this one was factorable. You do know it's a quadratic opening upwards. So again, I'm going to pass on putting that in the calculator because we don't have a calculator one. But we would just look at the calculator, or you could do the quadratic formula. Kyle, say it's the second day. She sat there like a couple of days. Kyle always sits in that spot when we do cards. And you would. Okay, so again, I'm just going to pass on finding the zeros. I know you guys can use decimals and the calculator and find your zeros. Okay, neither of them are going to be extraneous roots because they're not going to come out to be 0 and they're not going to come out to be 1. So then last one, same deal, or last equation I should say. We're going to multiply out. I'll bring that 12 over. We will simplify. I think this one was factorable, right? 2x, x, 4, 5, positive, negative. So you get 5 halves and negative 4, but negative 4 is extraneous. So you wouldn't include negative 4 on the answer. I think we have one more. Yep, one more. Okay, so last one, right? So what did I do? I factored the numerator, took an x out. Denominator's not factorable, so this is just straight up sine graph. So sine graph for 0 is normal. Sine graph for negative 2 is normal. Sine graph for 2 is normal. So denominator I don't need, it's all positive. So those are my answers. It's equal to at numerator zeros, and it's less than here. So negative infinity to negative 2 close, and 0 to 2 close. I think that was the last one. So any other ones that are issues? Say that one more time.
Ladder is extraneous in one of the questions. What is that?
When you say that word like ladder, it's usually like a list of stuff, and the last one would be extraneous. Yeah, I think that's what they would mean by that. It was in the answer key.
Yeah.
Do you remember for which number?
It was 442.
42. All right, so they won't give me. I can look at those answers in a second. They just don't give me all the answers back here. 42. Oh yeah, they probably listed negative 4, right? So the second answer was probably negative 4, and that means the last one is extraneous. So okay, any other ones on that, guys? All right, so you guys were supposed to do that one, right? So let's kind of check with each other, check your answers on 2 with each other. All right, so maybe somebody say the answer that you got. See if people agree or not.
You know what?
Any disagreements on this one? Does anybody want to see work on this one? We are going to start with one that has multiplicity. So we are going to start with. So do this one out on the board. So we've got a over x, b over x squared, c over x plus 3. I really suggest, happens every year when I do this, right? People tend to skip this line. Do not skip this line. Multiply through by your LCD, right? Because this line right here is kind of the base of how you're getting all of your answers. But people always tend to try to skip that step. People also would do x squared times x plus 3 times x plus 3 times x cubed. That's not the LCD. This is the LCD. So when I multiply by the LCD on the left, the whole denominator cancels, and x cancels, and I'm left with that, and x squared cancels, I'm just left with the plus 3, and the x plus 3 cancels, I'm left with the x squared.
So no, for the a over x, I just don't get how it's. Why wouldn't it be x squared times x plus?
That's what I was just saying. Right? So if we multiply by the LCD, do you agree that this whole thing cancels with that whole thing? Right? I'm multiplying this by everything in the equation. So when I multiply this piece right here by that, this cancels. So I know what you're doing. You are taking this and multiplying it by this one and this one. That's not the LCD. You're making the LCD x cubed times x plus 3. Right? And if you do that, you're not going to be able to solve it. So that's why I'm saying don't miss that step, because you can immediately see if you have an error if you're with your LCD if you write that. All right, so now I'm going to go to convenient numbers, 0 and negative 3. So 0 cancels A, cancels C. I have 3B, B is 1. Negative 3 cancels A, cancels B. I have 9C. C is 1/3. I always pick matching coefficients. Always. I just don't like any number. So matching coefficients, I'm going to multiply that part out. ax squared plus 3ax. I'm going to multiply this out. bx plus 3b. That's on its own. I'm going to put it right underneath the x squared. That has to all equal 3. So that verifies that b is 1. If c is 1/3, I don't have an x squared over here, so a has to be its opposite. So a is negative 1/3. I didn't use this line at all. So I could check myself. 3 times negative 1/3 plus b, which is 1, has to be 0. And it is. So it's kind of a built-in check. We're going to have a couple of built-in checks today. Okay?
So when you get that there's 3b, how does that get you to b equals 1?
Doesn't 3 equal 3b make b 1? Right? You have to plug in the convenient number on the left and the right, right? And there's nothing to plug it in on the left, so it's just 3. Okay? Yep, right here. A plus c has to equal 0. There's no x squared term. So if c is 1/3, then A has to be its opposite, so it cancels out.
What do you mean by there's no x squared?
Over here, there's no x squared term. So the left has to equal the right, the left has no x squared term, so it's going to cancel. We're going to have more of those today, so you'll be able to see them. Okay? All right, so the one that we're starting with is number 3. So let's set up number 3 all in the exact same manner, right? Because I want everybody starting with getting all of the same variables first, right? You're going to remember, it doesn't matter the order in which you do your variables, but let's set this one all up to be the same. How many denominators or how many fractions are we going to have to split this in? Right? 3. There's only 1 0, and it has a multiplicity of 3. So I want everybody setting it up in the same manner. I like to start with multiplicity of 1, multiplicity of 2, multiplicity of 3. I thought I fixed my pen today to keep the colors, but obviously I didn't. Right? Factors or zeros. Okay? All right, so we are going to multiply by the LCD. Right? LCD is x minus 3 all cubed. So I think it's helpful to write it right over there. So on the left, the whole denominator cancels. So on the right, I've got A. One of them cancels, I have 2 left. On the B, 2 of them cancel, I have 1 left. On the last one, all 3 of them cancel. Since C is a constant, can I automatically say C's negative 5 because it's going to match the constant on the other side? Can I say that? Why not, Charlie? But why? Like, because it could work that way. For this one, it doesn't.
Loki could work though.
Why doesn't it work though? Why doesn't it work? Why doesn't it work? Penny?
Because constants and the x minus 3.
Right? Good. Right? This is going to be a constant, and that is going to be a constant. So if it's the only constant, then yeah, it would have worked, right? But it's not the only constant. Julia, what's my convenient number? 3. Please, always like convenient number first. So I'm going to plug in 3. 9 minus 3 minus 5. That's 1. I'm going to plug in 3. Cancel A. Cancel B. All I have left is C. So C is 1. Any more convenient numbers? Any other way I can plug numbers in and get some zeros in the denominator? No. Right? So you got to choose another method. You got to choose either matching coefficients or any number. So you guys choose, right? In your group, decide what you're going to do. Right? Decide what method you're going to do. I choose matching coefficients. When I choose matching coefficients, I can automatically get A. I can get A just by looking at it right there, and it's not because I'm a math teacher. How's A1?
You distribute out that x minus 3 squared, you get x squared minus 6x plus 9, and then you distribute the A, you get ax squared, since it's the only x squared on the right side.
Perfect. Yeah. It is the, you can tell there's no x squared right here, right? So you can say the only x squared term is going to come from here, ax squared. That has to match that one. So A's got to be 1. Right? So again, that's just kind of doing everything out. If I multiply that out, I'm getting x squared minus 6x plus 9, and I have to multiply them all by a. Right, so I get that. If colored things help you, then take b and do b a different color. Bx minus 3b, right? That's my b term. C is a constant. I already solved C being 1. So I'll put it there, but then I'm going to go, all of those have to equal that, and C is 1. Right? So we're using that value. Can't you visually see that A is 1 right there? Right? A is 1. So right here, it's the only term with A squared. A is 1. Caitlin, what am I going to do with that A, do you think?
Put it into
Why-
the
why-
Yeah. So A's 1, I'm going to put it right here. I get 6x. I'm going to put it right here. I get 9. So now I'm done, pretty much, right? Isn't B 5? Right? Because negative 6 plus 5 has to equal negative 1. So B is 5. I didn't use this row at all to solve it, so that's a check. 9 minus 15 plus 1 is supposed to be negative 5. It is, so it checks. All right, so it's like a puzzle. You get one thing, you put it into the next, you put it into the next. Okay? All right, I'm going to change the order of how I did it in the other class today. So we have to do some quadratic denominators, and we also have to do degree of numerator is bigger than degree of denominator. So I'm going to go that way first. I'm going to do degree of numerator. Is that the one? Nope. This one? Yep. Degree of numerator is bigger than degree of denominator. Okay, so degree of numerator is equal. Degree of numerator is greater than. So we said that the degree has to be less than. So what you have to do, right? This is like the improper fraction one. 11 divided by 6, right? That is going to be 1 plus 5 sixths. Quotient plus remainder over divisor. So that's no partial fraction stuff. So then I'm going to take this 5 sixths and I'm going to say, okay, what denominator of 2, what denominator of 3, numerators of 2 and 3 were used to get 11 sixths? That's what we're doing on these problems, okay? So on this first one, we need to do long division first, okay? You have to do long division. So I'm just going to give myself another slide, right? Because I know I'm not going to have enough room. Please don't let the long division be the part that trips you up. Because this long division isn't really that bad. So divisor, 6x squared plus 5x plus 1 going into 6x to the 5th, 7x to the 4th, 9x cubed minus 2x squared. I don't have a 0x, I don't have an x term, so I'm going to do a placeholder of a minus 1. So it looks overwhelming because that polynomial is so big in the dividend, but it's really not that. It only takes like 2 parts to divide. So remember long division. 6x to the 5th over 6x squared. Right? So that's your first part of long division. That's x cubed. So x cubed goes up top. I multiply by the divisor. That's 6x to the 5th plus 5x to the 4th plus x cubed. Is everybody okay with long division so far? What do I do right there? What do I do when I draw a line right here? Add or subtract? Subtract. So I like to change my signs. Cancel. Negative 12x to the 4th minus 10x cubed minus 2x squared. Bring down. So you guys try the next piece, right? You're going to do negative 12x to the 4th divided by 6x squared. Right? You guys try that part, please. It should be nice after that step. Isn't that it, right? Everything cancels, you get 0, and you just have to bring down the negative 1. Right? So you're done. You're done your long division. So I'm going to back up a little bit. X cubed minus 2x squared. Okay, so when I divided, I got, what did I get? 2x squared? I can't even remember. Thank you. X cubed minus 2x squared. So I got x cubed minus 2x squared plus negative 1 over 6x squared plus 5x plus 1. Right? That's just the long division. So now you're going to take the remainder and partial fraction the remainder. Whoops. So I'm going to take negative 1 over. I'm going to factor that. 3x, 2x, 1, 1, plus, plus. So this is why I wanted to do this one first. Because those are just linear denominators, right? That's not hard. So each is a linear denominator. So I'm going to go a over 3x plus 1 plus b over 2x plus 1. There's two convenient numbers. Go solve for a and b. They're fractions, but it comes out nice. Right? It comes out with integers. If I give it to you as a division one, I won't make the denominator too hard. Right? This is the only extra step on this one is the division. I think they both came out nice. I want to remember like 1 and 2, one of them might be negative. I really don't remember the answer. I think one of them's 2, I think one of them's 1, I think, or maybe 3. That's what this is. Alright, so I'm plugging in negative 1/2. it cancels A. And I plug in negative a half and I get negative 1 equals B, right? That's negative 3 halves plus 1 is what? Negative a half. So I multiply each side by negative 2, and B is 2. So then I do the same thing down here. I get negative 1 equals 2 times negative 1/3 is negative 2. So negative 2/3 plus 1 is 1/3. Multiply both sides by 3. So A is negative 3. So make sure you're looking at your final answer, right? Your final answer is quotient x cubed minus 2x squared plus negative 3 over 3x plus 1 and 2 over 2x plus 1. So the whole answer is quotient plus partial fraction remainder over divisor. So I did the harder one on those, right? You guys do number 1. Right? You guys do that one. You guys do that one. You guys do number 1. Number 1. Right? It's n equal to n. N equal to n. So you're going to divide. Hopefully you're going to see the quotient's going to be 1. You guys are trying number 1. I'm just giving myself more room. Just do the long division. Negative 4 and 1, it looks like we have some answers on. So in my red rectangle, all the way to the right is my division. So in my little weird shaped thing is my quotient plus remainder over divisor. Then in my red rectangle, it's my partial fraction setup. Then this is going to be my partial fraction work for key numbers, or convenient numbers, sorry. So then my final answer is right there in that last rectangle.
This way, on the test, you have the denominators in those two fractions switched around, so we have different ways to case it for this number.
As long as the 1 is on top of the x plus 1, and the negative 4 is on top of the x plus 2.
Alright.
So what I'm understanding you're saying is that if it looks like this, isn't that the same answer? Right? A plus B plus C is the same thing as A plus C plus B? No, the one is, you ignore the one when you do the partial fraction, because it's not a fraction, right? That's the part that took care of either equal to or greater than. So you're just, so that's why you see my final answer has that one in it, right? So that's why I kind of like, whenever I do this, I always set up my answer right there, because people are going to forget that. And if you forget that, your answer's wrong. Okay? So greater than or less than, not, I'm sorry, greater than or equal to, not that hard, right? I think the harder ones are when we have some quadratic denominators and multiplicities. So that's why I kind of like saving those until like the end of the class. Okay, so what I think you guys should be good with now, right, is this set of problems, right, whether they are linear, linear multiplicity, or greater than or equal to. So the ones that we're going to do now are going to be quadratic. I don't know if I want this quadratic one. Hold on, let me look at the other one. Yeah, let's try this number 2 one. Right, let's try this number 2 one. Molly, how do we factor that denominator? X squared plus 1, x squared plus 6. Yep, that's the way we are going to do it. Again, I'm just going to give myself more room. I don't know why I didn't make all of these on their individual page. All right, so Molly gave it factored. X squared plus 6, x squared plus 1. So I got 12x squared plus 47, x squared plus 1, x squared plus 6. So, VA, how many fractions do you think we're going to need? 2. 1 for each, right? So you got 1 for x squared plus 1. You got another one for x squared plus 6. All right, so Sophie, what's the degree of both of those denominators? 2. Degree is 2. All right? So in order for n to be less than m, you're going to make this degree 1. So ax plus b, cx plus d. If it needs to be a constant, then a and c will come out to be 0. Right? It needs to be a constant. So if the denominator, irreducible quadratic, right, has a power of 2, you are always going to make it linear up top.
Why can't that just be an A and a B approach?
Because it needs to be a degree less than 2. So it could be 1, or it could be 0. So you have to make the numerator the biggest possible thing that it can be so that the math will work. And if it's supposed to be an A and a B, this will be 0 and that will be 0. So always make it linear, always. All right, so we just got to multiply, right? So let's see, 12x squared plus 47 equals ax plus b times x squared plus 6 plus cx plus d times x squared plus 1. All right, Lucy, how about convenient numbers? What makes those denominators 0? positive and negative rad 6, positive and negative rad 1 by i's, right? Because it's a sum of squares. So no zeros, right? So you got to use a different method, right? So there are no convenient numbers. So if you want to use any number, then you are going to pick 4 any numbers, right? And plug them in. Again, I'm just telling you, I'm not an any number person. I always go for matching. So if I'm going to go to matching, I'm going to multiply out ax cubed plus bx squared plus 6ax plus 6b. When you multiply, try to write it in descending order. So 6x cubed plus bx squared plus cx plus d. So again, I'm stacking as I go so that I can see similar terms. Similar terms. So I know the x squareds have to add up to be 12x squared. I know the constants have to be 47. Can anybody tell me what A and C have to be? Why 0? Because right here, it says they have to cancel out to be 0. So that could be 5, that could be negative 5. That could be 10, that could be negative 10. Why do both of them together really tell me that they have to be 0? Right. So again, if you don't believe me in terms of that, you're going to do a system. You're going to say A plus C has to be 0. You're going to go 6A plus C also has to be 0. So you're going to say, okay, I'm going to multiply it by a negative. I'm going to get 5A has to be 0. A has to be 0. If A is 0, I'm going to plug it in. And I also get C being 0. Right? So see, Caleb, how the math told me I didn't need that. Right? But I wouldn't have known that unless I put it there. Right? I wouldn't have known that. So A and C are 0, so those disappear. All right, you guys solve for B and D. B plus D is 12. 6B plus D is 47. I think it comes out nice. So I'm going to do simultaneous equations by multiplying the top one by a negative. You get 5b equals 35. B is 7. So if B is 7, I'm going to go plug it in. And D is 5. So then my final answer, 7 over x squared plus 1, 5 over x squared plus 6. So again, convenient numbers weren't any, so I had to do something different. Ended up being systems of equations. It wasn't that. Okay? Let's do a linear and a quadratic together.
How would you write that answer?
Right here. 7 over x squared plus 1, 5 over x squared plus 6. All right, so let me look what I have for a combo one. Let's do this one. Let's do number 1. you do whatever you want to solve for 1, right? Set it up. Maybe you want to set it up in the same way as the people sitting next to you, so you guys can check some answers. So maybe do x plus 2 first, if you want to set it up in the same way. All right, you're doing number 1. Number 1.
Linear on top of the square. It always has to be 1 less than. So 1 less than would be plus. Yep, so that's nice because it's going to be. So it's nice.
What are you guys going up to? C on this one, I think? Right? C.
Okay, now it wants to be delayed, I think.
Why does the bx plus c have to be over the x squared plus 1?
Yes. Because the degree has to be 1 less than to set up. 1 less than to set up. See how I plug that red one to get 1 in? Right? Put parentheses around this, right? Because that is all multiplied by that. So now you just need to pick either any number or match it. I chose match. So that has to match the red. Right? So you see all my red and black stuff over there, right? So I took the -1 and I multiplied it through the A and got my 2 red numbers, right? And then I took the 2 green ones with my black arrow, I multiplied those out and I got all the black numbers, right? So then that has to equal the left. So linears have to add up to be 3x. Constants have to add up to be 1. So you're going to use that to help you solve for these
And I think you can get B like that. Why can you get B like that? What's underneath the x squared? Nothing, so those have to cancel out. So doesn't B have to be 1? Right? And then once B's 1, you're gonna go plug it in that one. Like you see it's being 1. And then you can use the last one to check yourself. You plug it in, you make sure it works.
Right, so convenient numbers, I got A, B, and -1. Right, so then I did match up. I have no x squared terms. So B's got to be 1 so that they cancel out. So then if B is 1, I'm going to plug 1 in right here. And I get 2 plus C has to be 3. So C's got to be 1. So I've got all 1s, right? All 1s. So that's my answer. I can use this last one to check. If C is 1, -1 plus 2 is +1, it checks. Last one, number 2. Let's set it up all in the same way, just so all of our letters match. Right? All of our letters match. Theo, what do you want to be our first denominator? X plus 1. Perfect. So that means I'm going in A up top. Savannah, what do you want our next denominator to be? X squared plus 1. Perfect. So that's quadratic. I need bx plus c. Arya, do I need another denominator? What is it? X squared plus 1 all squared. Ella, what do I need up top? Nope. Dx plus c, right? Because you're looking at your factor. I really don't think I ever go more than e. That's what you need to solve. I got -1 for 1.
But when you plug
That's what I had as the answer.
if you write x plus 1 as the answer, it will answer.
Don't I have that as my answer? Alright, I've got -1 over x plus 2, 1x plus 1 over x squared plus 1. I'm just going to say go and do it. This one's fun. Charlotte's going to be crazy because look how much room she left for this problem. She needs like this is for her. The big one. The big one. Don't try to squeeze it in. This one's a fun one. Fun, fun. I'm already writing too big. I'm going to write the first step up here, guys, and the bell is probably going to ring while we are in the middle of solving this. So I want you to make sure your setup is matching my setup. All right, so make sure the setup line matches that. I would suggest you doing convenient number first. Austin, what's our only one convenient number? And what does that solve for? A, B, C, D, or E? A. So that is my suggestion for you to be successful on this one.
You said you write 1 less than the degree, right? So,
1 less than the degree of the factor.
of the factor, so the factor for the third thing is x squared plus 1 squared.
No, the factor is x squared plus 1. It just has a multiplicity of 2. So you have to look at the factor. You have to look at what's inside the parentheses. no, I told you that. Let me see if I have my cursor. Just when the bell rings, don't get over. Guys, let's go. There's no way you've done this, Charlie. Let's go. Did you guys get A? What was A? 1, -1? I forget. Was it 1? Right? So this one is being added to your homework. Because this is an awesome one to solve. This one's a tough one. Alright, so A is 1. Alright, A is 1. My suggestion is, right underneath here, right with those multiplied, x cubed plus x squared plus x plus 1. Then take bx, multiply it all through, c, multiply it all through, and stack. If you don't stack, you are going to run out of room. So this one's added to your homework. Because this one over here, so when you do this, I just leave spaces so you're linear. Okay? The homework is 7-4 on the homework sheet, and that one. Okay, 7-4 and that one. All right, let me go grab one. We just did 2-7. Like, were you